So r equals 5 cosine 1 theta to the right, polar axis symmetry. R equals 5 cosine 3 theta to the right, polar axis symmetry. R equals 5 cosine 5 theta to the right, 5 petals and polar axis symmetry. R equals 5 cosine 7 theta. The head is to the right. We've got 7 petals and we just have polar axis symmetry. Notice for each of these with an odd number of petals for the cosine, and I've made each of these positive, as you can see, we're headed to the right, to the right, to the right, to the right of the theta equals pi over 2 axis, but we only have polar axis symmetry. Always to the right with a positive cosine. When we're talking about an even number of petals, we have to double the number of petals. Notice this 5 cosine 2 theta has all 3 types of symmetry. Well, for all of these, we have all 3 types of symmetry. And cosine loves to be bisected. You can see the underlying 5 cosine 2 theta underlying r equals 5 cosine 4 theta. But now we have 8 petals. Here with 12 petals, you can still see the underlying r equals 5 cosine 2 theta. But now we have 12 petals. Cosine loves to be bisected by the polar axis and the theta equals pi over 2 axis. R equals 5 sine 1 theta. That was a circle pointing up. R equals 5 sine 3 theta. That was our little bunny rabbit with its head pointing down. R equals 5 sine 5 theta. That was like a starfish with its head pointing up. R equals 5 sine 7 theta. That was this shape with 7 digits or 7 heads. I don't know. But the one that's bisected is pointing down. So we didn't see this. Positive cosine was always to the right. By the way, these are all positive signs. You know, if I put a negative, we're just going to flip this over the polar axis. Also, these odd ones, only have this theta equals pi over 2 symmetry, because we get that at least because we have sine. But this is the pattern I want to call your attention to. With the sine, 1 up, 3 down, 5 up, 7 down. Mr. Curran, that's hard to remember. All right, do what I did. Pick theta and get r and get that 1 point. Confirm for yourself where it is, and then you can judge everything off of that 1 point. Just a reminder, sine of an even number of petals. You're living in the quadrants. 2, we'd have 4, 1 in each quadrant. 4, you'd have 8, 2 in each quadrant. 6, you'd have 12 for a total of 3 in each quadrant. Notice that for each of these, if the graph would look the same if I put a negative in front here, although we'd just be reflecting these over the polar axis and keeping that theta equals pi over 2 symmetry. And for each of these, we have all 3 types of symmetry. But if I put a negative, remember top becomes bottom and bottom becomes top for the sine functions.